Yeah, we're live. So this is I guess a partly learning session, partly brain dump combination of things about some architectures that go back to all the way to February, and some ideas that we've learned since then, things that fit now, things that have changed, and so lessons learned also from, I think, a couple prototypes that we've done. I'm going to sketch it all on a whiteboard, so I'll share my screen. It's mostly focusing on the visual generative engine side of things, so the underlying generative tech with no interaction on top. So I'm going to share the screen now. Okay, yeah, seems to be working. Okay, so the big picture, like the macro zoomed out view. Oh, it's a different color. There's some kind of input context or data that goes in. It's originally called, well, Stefan calls it seed. But then as you feed it in, it becomes more like a context which you can keep using internally and passing it around. So in the code, I call it a context, so it might be passed around this visual engine here. The purpose of the visual engine is to generate stuff, in particular layouts that come out. I'm going to draw those in green. It's almost a fully specified document with stuff in it. Some details may be missing to make it a perfect SVG. And if that's the case, then we need the renderer. We can turn it into pretty much anything, in which case it becomes a PNG, SVG. Right now we're using HTML, and so on. It could be anything pixel-based, or even in the future, I guess, PSD, AI files. It seems awfully appropriate. And to JPEG. So I'm not going to talk about the renderer. Dennis has got some cool thoughts about that, and it's completely independent of what we're focusing on now, which is more the visual engine side of things. But within this, there's an extra, like there's a lot of stuff that can happen, and it's not clear whether we can right now design something that solves all of the world's problems in 2D design. But we have a very good idea of how to solve lots of specific domains, and as we sort of build up on those, I think we'll get a better sense of how to do 2D design in general, our layout. So I'm going to break this down now. So if we expand this out. So on the left, we have what we used to call a grammar, but it's kind of more than a grammar. It's more like a grammar hybrid expert system, hybrid procedural, hybrid declarative. And I really don't know what to call it, but I guess it's the closest thing to what we have right now. It's just a pipeline. So it is a pipeline that does whatever is necessary in any of these domains. Some things may work in some cases. So some things need to be procedural because you can't write rules to calculate complex colors from other colors. That needs to be something like fuzzy logic or neural network. So we need to make that custom. Some bits can be declarative because symbols work well, as classical AI found out. So declarative. And I think this is the key thing that I want to emphasize, that it needs to be hybrid. There's no other way around it. A declarative helps you prototype super quickly, but when you want the extra quality, you just have to write some code that understands the domain so well that it may use external libraries like text calculation, kerning, and all of these things. So being able to dance around between all of these things is necessary, especially as we increase the quality. Some things are more let's say expert system, some things may be learned. And Some things may be more like iterative bottom-up, some may be top-down. By bottom-up, I mean that you just repeatedly go over the context and add stuff into it. Just do it over and over. So in Slack, I posted this sort of taxonomy of all the different kinds of grammars, and that's more of an iterative approach, I guess. Fits into the taxonomy as well. Versus top-down. And so you can find gaps between the two, like blend a bunch of iterative approaches with a little bit of top-down. And so again, this is important to be able to jump around between these two, because we don't know exactly how certain things need to be solved up front. We need to have the flexibility. And that's where the sort of block-based approach comes in, that each of these different things can be blocks and customizable and modular. So top-down is more like one shot, I guess. But that's kind of, all of these are continuous scales, and we can decide where we want to be on these scales, depending on how fast we want to iterate, how simple it is, how complex it is, how production quality it needs to be, how much user control we need to have. And there's also another dimension which we haven't really explored yet, but is it interactive? Do we actually control the generation or not? And I guess some of Soren's stuff where we do actually control the generation may require blocks that need user input versus just a automatic. And again, the blocks are designed to find this balance with the widgets that Tero's currently improving on iteration number 27, and the more automatic side of things, which seems to be a little easier to handle than the interactive ones. So how is all this structured? I think the structure may change for different domains, and that's what I've been calling recipes or patterns or plans in a way. And they may be applied in different ways for different domains. And if we can find a grand unifying approach to this, or if we can find ways to reuse recipes from one domain to another, then that's where the winning conditions happen, because we can then generate slides from 80% reuse of what generates business card, and those are the winning conditions. But in some cases, we will have to have custom logic. The business cards by convention have these kinds of layouts with the name on the left and the logo on the right, and these are custom rules for each domain are going to be unavoidable. So I'm going to show you the kind of recipe that, or the plan, I'm not quite sure what to call these, whatever is most intuitive and useful. Let's switch back to green. So this is inspired by the stuff we did with the paint tubes and generating a promotional campaign for a paint tube. The kind of things that I would look into if I was taking this further, or when we take it further, the kind of things we can discuss. It starts with a bunch of very specific things that you can plug together in different ways. For example, we have a block, or internally it could be a set of blocks, or however it is, it could be one big Python code or plan or anything. It's completely modular, and there's a bit that's responsible for example, let's call it ranking, or grouping. So I'm actually going to hide what's inside of this and instead show the kind of things that it's responsible for. So in this case, we have the context, or the seed, that we feed into it, and it has data in it, like literally it will be a YAML file of some kind. And this sort of ranking grouping phase is something we've currently done manually, but we could have a block for this, which basically decides what's in group 1, what's in group 2, what's in group 3. This could be done automatically by saying, well, these two things kind of belong together by experience looking at these designs, or it could be done by the manual phase that decides, well, group 1 has to be the product image plus the 20% discount, so that would be the most important group. And it's kind of like a hierarchy in the Alexandrian sense, where you have more emphasis on group 1, group 2, and group 3. If there's only 3 items, then the groups are usually probably going to be obvious, like 1, 2, 3, or sometimes you might want to put 2 things in group 2, like we do in the visual layouts for the products. We have the product name, the hashtag, and the description could all be in group 2 of the same rank, and we don't need a third group. So this is currently done by hand, put it into the seed, but we could have some code for that, which could be a block, produces some stuff. We can send this new piece of data in the pipeline to another block, which does layout. And by layout, I mean the kind of things that Stefan has been designing, and kind of things that Dennis and I have been working on for that hack, figuring out what group goes where and all the different ways that can be done. So we could have the group 2 and 3 at the top, or group 1 at the bottom, or left side, right side column, whatever fits. Do we have gutters? Do we have all of these things? And just designing the overall structure of the document. We can do that once we have the concept of hierarchy decided, so we know where it goes. And again, this is a custom piece of code. In the case of the demo that we hacked together, it's basically a YAML structure that describes this, saying these are common patterns for promotional campaigns, and we've seen them in Nivea patterns, so we're going to capture those and put them into a set of templates which decide what structure we have. But we could also have a second approach to that, which is basically throw stuff together randomly and see what works. So that every stage of this pipeline, we could have different pieces of code running that we can select from appropriately. So the layout goes then into what I'm calling positioning and sizing. Oops. And this is one that's responsible for getting a rough sense of where things should be aligned. It's not necessary to calculate the exact positions, or maybe that is, actually, it might help later. But just having a sense of if this is left aligned or right aligned, does group 2 have a padding margin? Does it look good this way? And right now, all this stuff is hard coded within these templates. So we have like 40 pixel margin here, like 40 px on this product, so it looks good. And this is center. So in a way, in the current hack, we've merged this layout phase with the positioning sizing phase by adding annotations into the data structure that's passed from one of these blocks to the other blocks. But we could have a separate piece of code that does this, and we will need this as soon as we start trying to get really good visual quality. So deciding where group 1 is positioned based on the layout we've decided. Then moving into could be typesetting. And this is also hard-coded in the layout. For now, we decide, actually, it's the same font for everything, so there is no typesetting. And the HTML does that for free, so it decides how to break paragraphs. But as we get visual quality that matches professional expectations, we'll have to do this manually. So images won't need to be typeset, but text maybe. Does it need to be justified? Is it left aligned, right aligned? Are we breaking words in specific places because that is the best place to break a word? Do we change these various kinds of kerning settings to make it look good? So as a consequence, there may also be a separate decision sort of about font selection, deciding which of these fonts or font combinations, and this passes into the typesetting block. This is like a selection of fonts or suggestions that the typesetting can use. So each of these, I hope you get the impression that they're good, modular, well-designed pieces of code, and that's the focus here, is to make these useful to write in the way that a designer, visual designer that's got experience plus a good generative programmer can sit together and focus on this font selection problem together and really crack what that means. It may be a super complex set of blocks, it may be multiple different implementations, like the first version may be a complete hack, and the second version may be a neural network, and the third version may be fuzzy logic, and we may write many different versions of this until we get the quality we need in all the domains we need, but we just basically don't know this up front. And what we do know is there'll be some pieces of information that will need to feed through some of these blocks. And like to decide what fonts to pick, you might need to have a sense of what you're trying to communicate. So taking the output of this, the grouping ranking block, feeding that all the way in to the font selection via a little piece of data that says, well, this is what I've decided I want to communicate. Find a font that communicates that. And then this piece of code runs, or multiple blocks run, pick that font, and then pass it over to the typesetting. And then we keep going. Hope you get, I'm going to flesh out the pipeline that I prepared just for sake of completeness. This is not very close to what we hacked, but this is what I would work on if I was to take it further. There's the next thing I'm calling theme selection, or like deciding the overall colors. Now we have the overall typeset, the structure of the document. We can apply this as a separate phase, deciding what is one color and what is another. So what we have is the same layout, but along with that layout, we have a selection of colors that goes with it, saying, well, I want this color and this texture, and these go together well. And once that block is run, this is, I guess you could call this pipeline the sort of Alex's generative approach to generating stuff. And I think there will be multiple different overall structures of these pipelines based on who's working on them. But the idea is, by making these different blocks easily reusable, we can plug them together and create Sam's pipeline. This is how Sam would do this exact thing, or solve this exact problem, or solve a more general problem. So I'm not suggesting we use this exact structure, just a very modular approach of doing each of these things as a decision and deciding accordingly. So the next is texturing, coloring. And then we have the images may be styled and desaturated, saturated, whatever it needs to do. And the text is the backgrounds. These may be filled in accordingly. And then I think at this stage, I think you get the point. We can sort of hand it off to the renderer block, which I'm going to make pink in this case, and that becomes a separate part of the pipeline. So we can just do standard rendering. And then this turns into SVG, PNG, whatever. So that's kind of the overall approach. I'm going to zoom out a bit because that's not where it stops. Right, this is very focused on making sure we can actually technically solve the problem of generating high quality designs. But what we've come up with started with a discussion on the airplane with Roloff, and it was just before Copenhagen. And what we designed for Copenhagen was to take this and make it a useful tool that we can actually interact with and design stuff for and control. So each of these blocks is basically going to have a set of parameters which control how it operates and how things look. And these parameters are written entirely based on what the code could do. So if someone was doing font selection, then if that designer would take a certain set of constraints or requirements or anything, then we can expose these things as parameters. And they don't match at all to anything Alexandrian. They're purely there for the code. And the code allows us to do this, and therefore we're exposing this parameter. So what's missing to get this higher level control, us being able to explore space and control stuff that comes out here, we want to have control over this. So we need to basically affect these parameters. And that's where, well, there's two different approaches we could do it. First is just to randomly generate stuff, and then in some kind of optimization blocks or select the one that matches some criteria, and that's where this idea of judges comes from. And we can plug in judges that are constantly assessing judge number 1, judge number 2, judge number 3, and judge number 1 might be judge for white space, or negative space is a better word, or judging how much clutter there is. When you get the idea. And then another judge might be judging darkness, whether this is like a really dark design. Another one might be judging like 80s disco. Does it have lots of colors and is it playful? And so as we feed the outputs of our pipeline into the optimization process, we can then use these to evaluate some kind of aggregate fitness, and then produce a stream of designs that actually maximize or close to maximizing whatever parameters the user wants. So in this case, we could have sliders from 0 to 1. We want 50% white space. We want it actually or empty space. Nice clean design, like 80% darkness. It doesn't mean we should expose these parameters to the user necessarily. It's just these are the kinds of controls that we'll be able to use as weighting for these different judges. And then in this case, I want 100% disco because disco is cool. And so here we'll get then, as a result of feeding it through, originally this was written when we did this prototype the first time as a random optimization. So we're just searching random parameters, you're feeding random numbers here, and then you see what comes out. And then you pick the ones that match. And so it takes a lot of time, thousands of iterations to get the designs you want because it's random. But there are really good optimization algorithms today that allow us to do this much better. So the next step, which is something that Roloff suggested, and also Soren also came to the same conclusion independently, is to then establish a mapping between what we produce and these parameters. So now we have these sort of more Alexandrian properties here. How do we establish a mapping between those and these sort of low-level code properties that are about really the generative process? And the way we can do that is by sampling the space and learning the mapping from one to the other. So starting with potentially just random numbers, we literally just throw dice and see what comes out of the generation. So if each of those parameters are chosen randomly by a smart genetic algorithm, there's some really good ones that are suited to this, then we can check what is the mapping of these parameters and learn the inverse mapping. So we can say, now I would like to have, of all these 3 Alexandrian properties, I can then add an extra layer onto my whole pipeline and saying for these 3 different properties now, if, oops, I want to make that a different color. So if I want to do property number 1 at 70%, and property number 2 at 20%, property number 3 at 100%, these are all properties probably from the user, or what could be from another pipeline. Then we basically can do this with a type of neural network. It could be anything. We could hard code this as well, but it's probably going to be too complex to hard code, and then we won't be able to solve every single domain easily if we hard code it. It's a super tough problem, and people might have different meanings and understandings of these different high-level Alexandrian properties. Now, what disco means to Stefan when he's on the dance floor is something very different to me when I'm listening to YouTube videos. So we might have different meanings of what it means to be disco. So in Stefan's world of visual design and his custom tuned AI assistant, he might have a different mapping of what disco means. Disco Stefan, and there might be a different version of disco Alex. And this can all be mapped custom to each person with a neural network. However deep it is, this is a nice juicy problem for a machine learning engineer, but at the same time, it is not super difficult. Both Roloff and I felt we could solve this. So it's not difficult. We have however many layers we need inside the neural network that maps these inputs onto these outputs. Okay. Put a square around that. So the mapping process will basically involve computing what these scores should be inside each of these parameters, so we can then feed them in to say, you wanted disco, this is exactly the kind of parameter set that will, probabilistically, it's never an exact science, but generally speaking, if you feed in these values, you will get some good results. And if we pick the right genetic algorithm, we'll still get some randomness within that that allows us to learn distributions of numbers instead of learning exact specific values. So this is something that we would need to prototype. But using this, we can map what is this property space, let's call it that, from FCB Mexico onto the low-level code that we have to write. So this is I think the most elegant architecture I've seen that solves this problem in a way that scales. First of all, we write the code we need and we expose the parameters that we have. And so this makes it a solvable problem from an engineering perspective. We can have teams of 2 working on each of these blocks. Whenever we're in production, it's going to be a lot of work to get visual quality. And these teams can do so without having to worry too much about what it means to be Alexandrian. And then separately from that, we have some cool machine learning tech, which is, we think it's manageable, but still needs some de-risking to map these properties inputs onto outputs. It's the kind of problem that it's the bread and butter of machine learning, basically, which is okay. So we can handle it. So overall, this gives you a controllable architecture that is solvable from an engineering perspective. Also gives you high-level controls, and that we can start building without having these higher level properties at first. We can just do more generation, and then it'll be slower at first. We can just basically have the genetic algorithm find the right thing according to these judges. And the judges are written with specific code that identify what it means to be 80s, and so some of these could be learned also with different neural networks that say, well, according to this convolutional network, disco is when you have flashy red and flashy yellow and flashy blue in the same picture, and the neural network can pick up this pattern and detect it in a range between 0 and 100. And if we have that, that's a super easy problem to solve. We can write all of these blocks with first versions very trivially with basic computer vision, and then we can write new versions with neural networks later. Once we have those, we can already get this working without doing any of the complex stuff on the left, because it'll work, but it will just be a bit inefficient. We'll have to effectively throw out some of these because they're just a bit wasted. So a lot of the things that are coming out of the generator may not be actually disco when we wanted disco, but if we want to seed the generation so it's more disco, then we have to learn in sextro mapping, which can come a bit later. It's a nice modular problem, and we can treat all of this thing as a nice optimization problem, which should make things 100, 1,000, 10,000 times faster. But at least we can prove that it works with the tech we have, even if it does take us like 10K more items to generate. That's okay. We can pass on the costs to our clients from now and focus on building the code that we know we need for identifying Alexandrian properties and for generating stuff as a professional expert would. So of all the code we've written, we'll probably use all of it, including the templates, even if they're shitty YAML that don't recurse. We'll use some of those for sure, and we might use recursive templates that can plug in stuff, and eventually move into CFGs, CSGs, and so on. And so a lot of these things may use custom code. Some of them may use rule-based approaches. The only thing we need to be a bit careful about is stuff that we've talked about with Dennis. It's just to standardize this data that's passed between these different blocks and what it means to be like the context that these blocks operate on. And by doing that, by deciding a standard representation of what it represents as a layout, we can basically take this out and plug in a new one. Because it's a standard, it will allow us to quickly experiment and say, aha, I wanted to do my layouts with a completely different algorithm that I've just figured out, and it could be constraint satisfaction. I'm going to plug it in, and it will work fine modularly as long as we have the exact same input and the exact same output. So that's what gives us this bottom-up approach of being able to build stuff incrementally and swapping stuff out and improving them. And as we hire more people, maybe the layout will be a team of 3, maybe the typesetting, it turns out to be a team of 10, because that's kind of the thing that LaTeX does, and it's a tough problem. And then font selection, maybe a team of 2. And so by having these different modular blocks that we can incrementally update modularly, we don't have this big central bottleneck, which was a big issue, I think, of the constraint satisfying approach. Constraint satisfaction makes sense here and only here, I think, not as a big global thing that centralizes all of these requests. We may use constraint satisfaction within the layout positioning if we find that there's a block that needs to do these two things together. It's risky, and that's fine to do it a bit later once we have the first versions up using, let's say, common sense implementations that helps us make a good demo for getting FCB's checkbook open. And then later, if we find that there are edge cases or corner cases that our clients basically find unacceptable, we can fix that by incrementally replacing, merging, removing, interchanging, and learning, even potentially having machine learning in here somewhere to get to the quality levels that we need. This is also nice and modular in the sense that we can break down business cards into things that are specific to business cards. And I think a lot of that will be actually on the layout structure side. So business card will need a different layout structure than slides. So we'll be able to switch these out. We could do that also context sensitively and have a little flag here that says, if you're trying to generate a business card as specified by the seed input, then you're going to use this particular algorithm, which is specific to business card, or this particular data that's specific to business cards that was learned from examples. So yeah, we can also put stuff into the seed, any of these properties, if it helps us solve the problem. We can just take them and pass them through. All right, I'm going to stop talking now because I think I communicated what I wanted to communicate, and I think now's a good time for questions. It's looking kind of messy now. I alt tab back and just see how much of a mess it looks. Any questions, comments, thoughts?
Can you save JPEG of this for the sprint as well?
Of course, yeah. Yeah.
Because this might be useful.
Yeah, I would recommend you don't worry about the tech for the sprint. I think it's very good to think about, or to almost obsess about users now, because we've had a history of obsessing about the tech. So if you ignore the tech and say, well, what our users really want is this, then we will make the tech work. That's kind of that's the promise. Dennis will make it happen. So I will save it, of course. Just if there's a bias, I would encourage you to bias towards users, and if the tech can't do it, we'll throw all this out. I mean, I think it's a good architecture now, but if the design requires a different architecture, we should totally throw all of this out, if necessary, to produce what we need to produce.
All right. The only thing is my question.
Yeah.
How do those blocks scale? Each of them. I mean, because we still have to kind of find algorithms. So basically, identify scenarios, encode those in certain rules, constraints, whatever the block requires it to, right? And how does that scale? Because there's kind of a really huge design space when I mean decision space and algorithm space when you're kind of dealing with any kind of context, right? So how does that kind of scale?
So it scales better than it would by having one big central place that coordinates everything, where you put like a big optimizer there, because there's no interplay or risks of them sort of one affecting the other. And so in this particular pipeline that I showed, and it's what I would start with. My intuition says start here. It breaks down the problem into nice functional categories, I guess, different decisions that you have to make. And this is, I had like a 30-minute chat with Sam. It's enough to get a sense that these are all decisions that are part of the decision space, and we can make these partly independently, but informed by different data. So it scales in the sense that it is they're designed to be orthogonal decisions to each other, with the caveat that some of them might just take the same data as input, but they're scalable in the sense that each of them can be built and operated separately. If we find that some decisions cannot be made separately, then usually, and this is the case with planning in general, so we can use some techniques from the sort of planning communities that usually need a separate phase saying, aha, there's a really tough problem. And if we, for example, break this down before starting and decide on, I don't know, like before we even get to ranking grouping, maybe we need to decide on communication, like what do we want to communicate? And that may be an extra piece of data that we then feed into other blocks that they can use optionally. So it's scalable in the sense that each of these are independent, and by using this sort of standard Rosetta Stone representation to pass data between them, then we get this environment where we can easily drop in and out different blocks. And something that we may use, something that Stefan initially suggested, is iterating over these multiple times, and we can do like multiple iterations if we feel it's necessary. I think it's worth a prototype. I don't know if it'll actually work, but say after we've done all of this, saying, well, actually, could you pick a better font now? If I feed this exact same data structure that I was going to pass to the renderer, but instead pass it into the font selection, could you do a better job? And maybe for that, we need a completely even more holistic piece of code that may actually need to be learned at this stage. It might need to be another block, but the output of that would be just the same document, but with a new font selection that can then be applied again with another typesetting pass. So we can potentially do iterations here and decide if it actually improves the results or not. Is it something that the users want?
Would it be possible to generate these kind of blocks, these kind of encodings, algorithms, rules, / based on user behavior? I mean, the user basically generates the algorithm on the fly.
My gut says yes, but I don't know if we're talking about 6 months of R&D or 3 years of R&D. So I'm sure it's something that we will do in the future of the company. And I'm sure it will start as a 20% project. I don't know if it's going to be reliable enough, but I think if we hire the right people, and Rolof's got lots of ideas about this, and we put a small sub-team on it of experts in the field, they will tell us, yes, it is only a question of time. So this is also the reason for starting with something modular that works. Like if we can get the first version with YAML templates that are hard-coded, then let's do that. And then as we staff up the team, we'll find that, okay, our clients complain the most about the layout. Let's fix that. Let's put someone onto this and get a combination of great design, great tech, great machine learning, and fix that particular layout space.
I see. Okay. Makes sense.
So I think machine learning is kind of partly our cheat to scale, but also we can scale by breaking down the problem in nice modular orthogonal chunks, and that has disadvantages also, that some things that may be separate on the diagram I just drew may need to be done together, or we may need to run them, basically run one then the other, then one then the other, and do a micro iteration to say, okay, to really get the typesetting right, I need to do a loop of picking type and typesetting it, and picking fonts and typesetting it, and then until I've got what I'm happy with, and that could be super fast if we're doing a small loop with just those two things. And then after that, we exit and go send the result to the next phase of this pipeline.
The loop is kind of interesting because it's basically the relationship between those. Each module should be basically a module on itself, right? The
relationship between the different modules should be another module. Yeah, we could do.
Because everything kind of changes based on every other input you make, right? So every kind of, if you change something in design, everything is related to everything, right? It's kind of a big network of things.
Well, one way of solving it that would keep it modular, and I agree with you and Dennis on the importance of the data that the blocks share, is if each block is able to contribute to the context by adding constraints for other blocks, which means that a block would know if it's able to satisfy something, an additional constraint, or tell other blocks that it's done some work, but it wasn't able to satisfy a constraint, and then other blocks will know about this. So it would remain modular. It would allow for these micro iterations if we wanted, but also we could say, well, we're in this state, and it would get more information to the optimizer, saying, well, we're not sure that if we can get better than this, give us a fitness for this set of unsatisfied constraints, and we'll see if it's enough for the user.
Yeah.
I like this. I like this very much. I think the core of all this approach is this language of communication between blocks, because we really don't care about the specifics of any of these blocks as long as they can communicate. There is we've been thinking, Søren and I, we've been thinking a lot about the first 3 blocks. The grouping, ranking, the layout, and the positioning. The positioning being less important because we have ways of solving this. Mostly because they're the ones that catch the eye the most when you're a user, and you feel like you have more control if you can say something about those. But I like that we're broadening a little bit the approach, and that we can offer other levers. Sorry.
Yeah, I think the blocks.
Sorry, yeah.
Go ahead, Dennis. Yeah,
okay,
I was going to bring you into this anyway.
Okay. I was thinking on a tool or something like a pipeline visualizer, because our current blocks are getting more and more complex, and we are creating blocks of sub blocks or pipelines of sub pipelines. And even just for the render that I was working, I had to split the entire block into different mini blocks. So what I'm perceiving right now is that we need that our designers, they have to be able to see what is actually being outputted and inputted for those blocks. So what I think is that we need to have like a visualizer or a graphic UI tool to analyze or show to every one of us what is being inputted and outputted for that block or for that process. Because I think that's the only way we can work very closely between the production team and the designer team. Because sometimes I need to think like a designer, and the designer needs to think like a programmer. So I think it's the eternal problem. But a tool like that, now that we are growing our blocks and our pipelines day by day and increasing the complexity of everything, I think it's something very, very useful. And I think it's not only about building pipelines by drag and drop blocks into a UI. It's not that. It's just a visualizer that allows us to see the entire code or the messages flowing around those blocks, so that we can debug, not in real time, but plan and debug how those blocks needs to work, and how we can improve the process along the entire pipeline. Because I always try to work from bottom to top, like getting the example and then trying to get the examples from there. And the designers normally work from top to bottom. So yeah, normally as we want to have a very splitted and pluggable architecture like we saw right now, I think we need something like that to create something that visualizes the entire picture and allow us to create blocks by discovering properties and attributes that are in common from those blocks, and we can do that. So yeah,
the only thing to be very careful of is that we are using this as a tool to manage complexity, and that complexity should not be there in the first place. And this is what planners and behavior trees do extremely well, is that they break down the whole thing into really small chunks of stuff that should be obvious. And if we find ourselves building really large pipelines, that is code smell. And so it should be that you can give a name to a sequence of operations, and the name plus maybe a little description is enough to understand it. So I agree, it's fine to build visualizers, but not as a way for us to avoid architecting these things in a way that is clean and easy to understand by users. So if we end up with a spaghetti graph, then we've lost and we cannot get the users to work with the tech. And if we end up with short, succinct actions that look like Photoshop plugin names that have a clear meaning and a clear output, then we win. So it's yes, it's awesome idea, and we need to find that balance.
Yeah, I think it's not about knowing what's happening on each block, but knowing what is the information that comes in and out from that block in something like real time or something like that. Because right now we know that to define a layout, we have the classes and the layout. But what happened when, for example, for the render, I have like six different blocks, and I start with a layout, and when it becomes passing from block to block, the output increases and get more data that is more detailed for the render to render the poster. So it's not about what is doing every block, but how our layout information is being grown and fed from block to block. So everyone is okay with that behavior of each block. So maybe we have the layouter block, but maybe the output is not being as accurate as the layout block should be doing. Right? So it's about exposing the information for all the team, especially for the designers, and especially for the programmers, because we can do a lot of tests. We can do a lot of assertions about how the block should work, but if they are not aligned with the designers, then the block is not doing what we are wanted to do.
I think we can also extend Tiro's debug UI for that, and so you can click on stuff that's generating.
Well,
that's what I would call an MVP, actually, right? Visualizing this architecture, exposing the right parameters, seeing the behavior, how one clicks to the other. It's just a matter of kind of getting the level of details right. One would be for us to visualize and debug, and the other would be for an actual designer, right? But that's the actual MVP, right? You kind of have all of the parameters that go into each block, which is basically a decision block. You make that decision, you go further, you see the space, and so forth, right? And it goes in parallel with the tech, right? It doesn't add or change much, and we can basically, this acts as a prototype, and we can see the layers of complexity, how we can simplify, how we can group stuff together, and how people actually use it, right? We can bring in user data, we can test ourselves, we can test workflows, and that's basically an MVP right there.
So I was thinking when you were drawing the blocks and explaining their relationship, I was thinking back on the planner, and the way I see those blocks, I see them as operators in the planner, and because we don't care the order, we just care that all the constraints are satisfied. You know, the constraints that come from the desired output, but also the constraints that have been set by other blocks. So we may not need something as complex as this graph. We may just have a bunch of groups of blocks that can do stuff and that are selected by a planner to meet the constraints.
Yeah, the difference with the graph is that you get to see how it actually works without writing like 3 weeks of tech on the planner. Like, we don't have a planner right now. We have a sort of a hierarchical tree type evaluator, which is not really the planner in the same sense. So
I know, but it's not incompatible because, for instance, I was looking at the user interview stuff, and Andreas tweets recently about you have to find the lead element in the composition. If the lead element in the composition is the title, it's totally different from having an image, and so you don't want this. You probably don't want the same path or the same weight for these blocks. So we can talk about this, but I feel I'm in love with planners, so I feel like we can mix the approach these approaches and get something out of it.
Awesome. Then we're 5 minutes overdue, so I'm going to stop recording now. We can switch rooms and go into more sprint type thing. Awesome. Thank you for listening, and thanks for an awesome discussion.
Thanks, Alex.
Yeah, thank you.
See you on the other side.